Okay, first method is blind estimator. Estimator. Actually, what is the blind estimator? Coming from these two words, blind and estimator, this is how to estimate a random variable, let's say x, before we make observation. Yeah, before we make observations. Let's say this is a random variable RV, and we denote that the x, this is the point that we want to know, point expected. So then we want to make observations. So then we will get the x bar. Let's say x bar. This is uh, the point after we get observation, or we can say this is a sample. So given the 2 point here, we can measure the error. The error. The error we can simply compute as differences between the expected point and the observed point. Okay. To make the error become robust, then this error we power by 2, and then we get this expression become like this. Okay, and then for example we make at least n sample. The n, for example, equal by 3 sample. So the first error, we can say the x minus x1 observations, and then the error 2, x minus x2 power by 2 observation, and the error 3, we can make this minus power by 2. So in this case, what is the average error? Average error. Average error, we can simply this one, and then x minus x1 plus x minus x2 power by 2 plus x minus x3 power by 2, and then something like that. So this n is divided by 3. So this is equal to this one. So this one is actually this is the average. The average mathematically we can write being expected x minus x something like that. So I put here. So in this case, the error powered by 2 or error square, we can write x, we can extract this one plus x powered by 2, yes, and then average here, and then you remember how to minimize the the error. Actually, we have to make a derivation, this one respect to the x tau equal to 0, right? This is a maximization or minimization, yeah, minimization. So we derive this one. For first derivation. So in this case, this is equal to the because we don't have a variable x bar, so the first is 0 minus 2x, right? uh, uh, Plus 2x bar, like this, right? Being 0. So in this case, the x bar equal to the x. In other words, means that x bar can be defined by the expected value of x. What we can conclude from this one, actually, the blind estimator suggests that uh, the best estimator, yeah, the best estimator without any knowledge about the random variable f here, actually is the average of observation. This is the average of our observation. Average of observation. Okay, this one. This is the average of observations. Thank you.